Very good afternoon, one and all. Hope it is audible and good for everyone to hear. I'm Vinod Vijay Kumar, Director of CAAD, Chennai Academy of Architecture and Design. I'm extremely delighted to welcome our guest speaker for today, Architect Kimmy Dash, the Sustainability Consultant at Max for Them LLP London. It is an honor to have with us our founder chairman, Professor Dr. V.R. Rajendran. I welcome all the CAD students for this lecture. I'm imagining that their family members who are interested are also viewing this session. Welcome all. I welcome my colleagues from CAD and other associates of CAD from the practice fraternity who have gathered to enjoy this Friday afternoon through this wonderful lecture, Going Beyond Efficiency, the Role of Architects. A special thanks to my colleague, Architect Shiva Shankari, for coordinating with Kimmy and bringing her on board for the lecture. Our chairman, Professor Dr. V.R. Rajendran, has held the highest positions in academics as the Vice Chancellor of Universities, appointed by the University Grants Commission, Government of India. He is a government-nominated member in many universities and councils in India, such as the Pharmacy Council of India, the Indira Gandhi National Open University, and the Periyar University. I request our chairman to welcome the gathering, please. A few quick words from you, sir.
Unmute your mic, sir, please.
Okay. Okay now?
Yes, sir.
Hello?
Okay, sir. Yes, sir. Okay, sir.
Yes, sir.
Can I go ahead? Yeah.
Please go ahead.
Welcome and greetings from CAAD. CAAD, Chennai Academy of Architecture and Design. CAAD is a standalone college dedicated only for architecture education in India. Today is the continuous, uninterrupted lecture series of CAD, which is going on since the inception of the institution every month. The pandemic COVID-19 has turned down the world ups and down, shifted the pattern of working of industries, educational institutions, and livelihood of human beings. Educational institutions are now focusing more on online education, online teaching and learning methods. The online teaching and learning methods are not a new one to CAD, since CAD has been adopting this online teaching and learning process along with its regular mode since the inception of this institution. I congratulate the director, Professor Dushyant, Professor Shiva Shankari, Professor Tamil, faculty members and students for making the architecture education in CAD a great success in India. At this juncture, I am very much thankful to architect Kimmy Dash from London, who has consented to give the interesting lecture today amidst her busy schedules. Thank you very much, ma'am. Thank you. Finally, I wish that everybody should stay at home as far as possible, follow the social distance, wear the mask, and stay healthy. Health is wealth. Wish you all best of luck and welcome you again. Thank you.
Thank you, sir. Thank you very much, sir.
Thank you.
Let me give a quick introduction to the event and our institution, since we have a few hundred more first-time viewers for this lecture, both from India and abroad, thanks to the technology. CAD is affiliated to Anna University, one of the oldest technical universities in India and approved by the Council of Architecture, India. It is one of the very few standalone architecture institutions purpose-built for a studio-based design course such as architecture. Holding the office of the Vice Chancellor of an university for 2 terms, our chairman has a very strong penchant for quality in academics. My specialization is in planning and urban design from National University of Singapore, working with international practices for several years based in Singapore. One can see a blend of good practices from the profession and academia at CAD. As the chairman just now mentioned, ever since inception, CAD has built a tradition of constantly developing academia and the profession through the regular lectures that we used to host at our premises. Coming from the practice myself, I always thought it is important to give the students a perspective of academics from the practice point of view, and therefore we built this platform called the CAD lecture series, which is an open forum for architects and professionals from allied fields to present their works and philosophies. This platform has helped our students to build their focused interest in key disciplines related to architecture and set their future career direction. I wish to give a quick introduction to the speaker. Architect Kimmy is an architect with a mark from the prestigious Architectural Association London, UK. She works in the Max Fordham Sustainability team as a sustainability consultant, providing focused consultancy services for clients dealing with issues that cut across sustainability and climate change aspects of the built environment. Her scope of services span from certification, embodied carbon analysis, net zero carbon advice, and building performance. She has assisted design teams throughout the process of BREEAM certification, framed design guides intended to improve the design of social schemes, focusing on design strategies to improve building performance and occupant comfort. A very interesting, she is extensively working on a niche area, embodied carbon analysis for different projects, highlighting to architects and engineers the impact of their material and system selection. I should say that the topic is very intriguing. I would imagine that we are going to deal with a lot of tangible aspects of sustainability in this lecture than speaking of it just as a good to have feature in projects. We are keeping it very open and we are keen to listen to you, Ms. Kimmy. I request Mr. Dushin to connect to Ms. Kimmy for
Prabhavara.
Ms. Kimmy, are you able to go ahead and speak?
Yeah.
I mean,
Hi.
Am I sharing my screen?
Not yet. I think in a moment. Not yet.
Is it sharing now?
Yeah, I think it's streaming right now. Great.
Can you all see it then?
Yes, yes. Thank you. Over to you.
Thank you. Thanks for having me. I'm going to start with a slight apology. The presentation is going to be very much focused on UK-based figures and Ireland-based figures. So, but I hope it's still of use. So, the title, Going Beyond Efficiency, the Role of Architects. So I want to do like a little brief introduction about what I'm getting at with this. So over here, we design very much, it's a cold climate. So we have to sort of wrap our buildings in insulation and make sure we can retain the heat. So, and we also install a whole range of different technologies and things to try to make the building work as efficiently as possible. So my proposal is, and this is the work I did at the AA for my master's, which is let's go beyond that and let's see what the architect can do through design to improve the building performance. So just a couple of concepts: environmental design, which is the process of addressing surrounding environmental parameters when we're doing our plans and buildings. So a lot of what architects do naturally. Passive design is a system that uses natural energy such as sunlight, wind, temperature differences, or gravity to achieve results without electricity or fuel. So essentially, the idea behind this is that you use what's available to you. You use the sun, you use the heat, or you keep it out. You use the daylighting capabilities that the sun gives us, and you design with that in mind. You take into consideration what our surroundings are. So say if it's a cold climate, as I was saying earlier, we try to keep that heat in. If it's a hot climate, you try to keep that heat out. So you take advantage of ventilation strategies and you control the solar or free energy that we have from the sun. We control that for whatever our needs are. And that ends up sort of developing different typologies in different climates. And the judge of all of this then is us, it's humans, and how comfortable we are or aren't in a building. So why is environmental design and passive design strategies important? We are in a lot of the energy that we use, be it electricity or the fuels and stuff, they come when they generate a lot of carbon, they release a lot of carbon. And this carbon, when it stays in the atmosphere, it retains heat, which is causing the problems that we've been hearing so much about, global warming. And as the population increases, this demand for energy increases, and most of it is generated from fossil fuels, which release these carbon emissions. So it's greenhouse gases, which have been sort of summed up into carbon. So I'm going to be talking about carbon, but it's a range of different gases that have this ability to retain heat in the atmosphere. So if we continue releasing carbon in the way we are going to go down a scenario of within a few years heating up to 4 or 5 degrees potentially. So what we need to do is try to reduce the amount of carbon we're releasing into the atmosphere to try to avoid this heating aspect. So we need to reduce this dependency on carbon essentially. So some figures from the UK. So annual emissions related to carbon emissions from the UK. And you can see that from buildings alone, it's over 40%. And so it's sort of broken down and operating the building. So using the building, keeping us warm, keeping us cool, or all the things we sort of plug into our building, refrigerators and TVs and iPads, iPods, and whatever. And there's also an element of it, which is the energy required for making the material. So extracting, manufacturing the different products that we use to build our buildings. So obviously we have a direct impact in the construction industry as we are the designers. And as such, over here, they have some countries have declared the climate and biodiversity emergency, and architects over here have actually signed a declaration and consciously working towards trying to mitigate this. So what is the architect's role in all of this, and how much can we actually impact? So I'm going to go through my thesis. So there's sort of two sides to it. The first bit was the research, so understanding where I am, and I'm going to look at these things I was talking about earlier. So look at the climate, my context, my surroundings, zooming into the dwelling, and then understanding the occupant. And then I'm going to take all that information that I gathered from the research and apply it to a design. And then at the end, we'll have a quick look at some numbers. So climate in Belfast. So there's a green band there, that's comfort band. So essentially, from a thermal point of view, you have to be in that band for people to be comfortable or within range of comfort. And as you can see, the temperature in Belfast is essentially always below that. We don't have much sun, but we can still take advantage of what we have. It's quite cloudy. It's quite windy also, so wind from all different directions throughout the whole year. And it rains a lot as well. And you have this additional factor, which is called the physiological equivalent temperature. So it's a combination of the wind velocity, the temperature, and the relative humidity, which actually gives you the sensation of a temperature. And that is at times 7 degrees lower than what it actually is outside. So now I'm going to look, so I understand my climate, I know what I have to deal with. And now I look at the city to see how the city has evolved. So from the 1920s, I do a quick timeline to the 2012, which is when I was working on this. 1920s, we have endless rows of terraced housing. So it's one house against the other, endless rows of this. As the decades go on, they start sort of being freed on site, these buildings. There still are several mid terraces, but not as long as they used to be. They're freer on site, and buildings, as you can see in the plans I have there, they're sort of orientated in all different directions. And we get to the point that in 2012-ish, so nowadays, because of developments with fabric, that insulation that we are able to put around the buildings to keep the heat inside, we kind of decouple from the outside, and we're able to have looser buildings on site. We have quite often semi-detached units, so it's only two houses, one against each other. But where do we go from this? So I'm going to have, again, as research, understanding how the houses from 1920s, what are the problems, what needs to be addressed, how they have been addressed in 2012, and then how can we go forward. So I start looking at the layouts for this terraced arrangement, and you can see like the proximity of the houses means that you end up creating these dark alleyways where you put your bins. So at times there's a smell issue, it's dark, there's no surveillance, there's nobody walking up and down here. Cars, there's no place for you to park your cars. You have kids with snow gardens that end up playing in the streets where the cars are. From the climate analysis that we spoke about earlier, if you're outside trying to open the door, because it rains so much and it's always quite windy, you end up getting soaked when you're trying to use. So the doors are always right on the street. So there's a couple of sort of issues that can be addressed there architecturally. Wind. So as much as there's a sort of sheltering factor from the proximity of these dwellings, we can also see that it does start picking up a little bit of speed. So zooming into the dwellings themselves, so this is one of the mid-terrace scenarios. So from the proximity of the dwellings, we start seeing the effects of overshadowing. And so here where you have an extension very close, you see how dark it starts getting. So this is daylighting. Let's talk about it a little bit. So the sun gives us heat and it also gives us light, all for free. So we want to allow this light in. in a controlled manner, obviously. And someone decided somewhere, they've done these studies. So you talk about figures of 2% daylighting in order to have average throughout a space. So here it's quite reasonably lit. There's some dark patches, but you can see the difference of the distance of the building here, how much it allows more light in, whilst at the back it doesn't. Okay, so proximity of the buildings start becoming an issue. The other aspect that I looked at was, so besides heat from gains from the sun, we as people, we also generate heat. The equipment that we have in the house is also generating heat. So when we're cooking and we're watching TV and things, we are generating heat. So why not take advantage of this as well? So that then is balanced with how much heat we are losing through the fabric. So heat flows from the hot of the indoors to the cold of the outdoors. So the larger the difference in temperature, more heat you will be losing. So in a climate where you do want to keep that heat inside, if you have a lot of exposed envelope, you're going to be losing more heat, especially in a scenario like this in the 1920s, where you don't have any help from technology, these insulent materials. So now I'm going to fast forward almost 100 years. Let's look at the 2012. Let's see what has improved and if there's anything else that we can do to help. So now we're talking, instead of having those long mid-terraces, we have semi-detached units. They are loosely spread on the site, mainly. We have the rear garden now, so kids have a safe place to play. There is car in curtilage parking now, so the cars are not on the street. They provide some sort of shelter for you to be protected from rain when you're trying to open the door of your house. So a lot of good development there, and we don't see those alleyways anymore, which is obviously a good thing. In relation to wind, this distance between the buildings starts allowing wind to pick up speed. So that potentially could be a bit of an issue. So before we were sort of always with lower speed wind, and now it's picking up speed a bit. So now looking at individual units, we see that distancing between the buildings allows daylighting throughout the whole building. So even in the middle of the plan, we're still talking 2%. That's not even averaging it out. But in relation to the losses, the internal gains remain the same. It's still the same people living in the house, the same equipment. But now we have 3 sides that are exposed to the elements. On the other side, these are now insulated so that we do lose less heat. So I run a couple of simulations and apply exactly the same sort of occupancy pattern, so the times that the people are in the house providing heat, cooking and watching TV and things. And I look then at what additional space heating demand is required. So this is very much space heating. The numbers that I'm going to be talking about are related to space heating. I'm not taking into consideration domestic hot water or anything like that. So first thing I want to point out is when we look at the 1920s, the buildings without the insulation, we can see how there's a lot of variance between the heat demand from the different elevations and between a mid-terrace, which is sheltered on both sides, and an end terrace, which is exposed on 3 sides, essentially. And we then, with this new design, have, even though we are always exposed on 3 sides, we have an improvement of from, say, 90 kilowatt hours per square meter per year down to 40 kilowatt hours per square meter per year. So obviously, this is really good because we have significantly reduced the energy demand. So what does this look in terms of comfort? Because obviously we are the judges. We will judge whether we want to live in this place or not. So we have to be comfortable. So the brown line here, it shows that the 1920 scenario never would reach comfort at no point in the year. So this is it's a free running living room. So it's the only heat input I have is from the people living in the house and from solar gains. There is no space heating. Now, when I look at the 2012 scenario, I can see that my living room is actually in comfort for a third of the year, essentially. So this is very good progress. So fabric efficiency, definitely something we need to keep on working on. It's quite useful. The next step then was, let's understand how people actually use the building. So I interviewed a few families and to try to understand what sort of techniques or how were they working their houses, the places that they live, and try to understand what did they do to achieve comfort, whether it was for sleeping or cooking or reading or watching TV. And what I actually was able to see is that essentially people open and close doors, windows, and curtains. And they know what to do. So after a lot of thought on this, I came up with three sort of important sort of conclusions from it. One is that our homes will have a direct impact on our comfort. It will sort of direct us into creating habits, defining actions which we will take to achieve comfort. And these actions, all of them have an anticipated thermal reaction. So I know that if I'm too warm in my house, I'm going to open the window and it's going to cool down, for example. The other thing is that I realized was that people are aware of the discomfort. They don't sort of sit there just waiting to be absolutely freezing before they take action. They know that, oh, when I start cooking, it's going to get a bit warm, so I'm going to go and open my window to counterbalance that. Oh, I know I'm going to close the door because I don't want the smells to go in and things like that. And the third element was thermal pathway. So we find spaces in our house where we want to do things. So, oh, I'm going to read my book in the morning in that room because that's where I'm going to get some sun from. That's where I have my natural daylight. Or, oh, I want a house that has a south-facing garden so I can sit out in the sun. Sun is a very valuable thing in Belfast because we don't have much of it. So people look for it quite often. This was also like just a quick analysis of when were people using heating or not. So the main thing I got from this was a definition of 3 periods in the year. So I have a warmer period, a cooler period, and then there's this intermediate period as well. So I bring all of this together to inform my design now. So I take the climate information I got. So I know I need to shelter from wind, from rain. This starts taking me into enclosing a courtyard idea. I know maybe I can even sort of have places for people to grow their own food. From the block analysis, I can see that the proximity of buildings and the distancing of buildings will allow me to access some solar gains, have good day lighting, or have these elements compromised. So that's an important analysis to be done. And the dwelling itself, what I start coming into, and Francisco mentioned this earlier in the week, is the sort of thermal gradient to access your building. And essentially what I'm trying to do is have my rooms that I need a lot of heat in, and wrap them with rooms that have, as you go outside, I have sort of a smaller heat demand. So the idea is that I reduce that temperature difference to which I'm going to lose heat. So I refer to this as buffer spaces, and I try to then use the layouts to create these. And from the occupants, these are the strategies that they use. It's opening and closing things, as I mentioned. So I know the design aspects I need to deal with. I understand my city, and I know my occupant now. So through an informed design, we'll do a little project then. So this was an actual project in Belfast. It's called The Village. So the government sort of surveyed these homes, and the ones that were sort of in reasonable condition, they refurbished and they added insulation to try to keep that heat in, changed the glazing so that it was double glazing and not single glazing. Some of the houses were beyond repair, so they had to unfortunately be demolished. So from a carbon perspective, maybe not the best thing to do, because you have to rebuild, so you have to manufacture more materials, you have to extract more materials, and there's a carbon side to that. But from an operational energy, from the energy we use inside the house, these new houses will probably be performing better, because we're going to have a lot of insulation and we're going to try to keep them quite warm. So phase 2, the green, was built, and I then was looking at the red site here. So now, very simple site analysis, just thinking of the things that I've been talking about. I have my urban fabric. There are strong lines that are within the surroundings, so I kind of wanted to keep that. I wanted to maintain this urban fabric lines that were apparent. I wanted that courtyard scenario to try to block winds, but I'm also concerned about my orientation, so I'm going to have to start turning my building because this is not perfectly orientated, let's say. I did a little study. So all the houses around here, the whole area is 2 stories. So I knew I wasn't going to go or too far above or too below that. So I do a quick shadow analysis just to see what sort of distancing am I talking, because I know the effective proximity of the buildings is going to have. So I look at the three sort of sample days to see the length of my shadow. And obviously, we can't put one dwelling there and you get sun the whole year. Absolutely fine. But nobody's going to want to build that. So there's sort of a balance between densifying the site so that it's sort of financially viable and still allowing people to be comfortable in their homes without sort of us ending up releasing all that amount of carbon. So there was an existing block there. So if I were to retain some like a line of houses here, I was going to end up with the same problem that I analyzed. So let's have the existing block as being the 4th side of the courtyard, and hopefully they will turn their house towards the back of it and now take advantage of the spaces that I'm creating. So help bring the community into the site as well. As I'm doing this, I start realizing that there's a couple of points, a couple of areas that performance will be compromised. So maybe dwellings, housing is not the best use of that space. I start sort of defining where I want my pedestrians to go, what sort of routes should they be, I'm anticipating that they're going to be using. And at the same time, I'm starting to look at my units and sort of playing around with the massing to see how many units can I get on site. So looking at the massing of the unit and specifically. So I had another decision that I had to make, whether I wanted a shallow plan or did I want a deep plan. So shallow plan means I'm going to have more exposed envelope. So I'm going to have more losses, but from a daylighting aspect, it should perform better. From a ventilation aspect, it should perform better. On a deep plan perspective, I have less losses because I have less of my exposed envelope. Ventilation, I have to think about it a bit more carefully, and daylighting, I will also have to think about it a bit more carefully. So also one of the things I developed a cluster which I want to be able to replicate throughout the site so that we have economies of scale as well. So I start sort of playing with my cluster to make sure I'm catering for all those issues that we were talking about: sheltering from the rain, sun access, making sure you're not, when you're trying to open your doors, you're not being blown away or things like that. And zooming in further now to the unit itself and looking at the buffer spaces, I identified the spaces where we need to have the comfort temperatures are a bit more specific. So those key spaces, living room and bedrooms. And I want to allow my free heat to come in. And I want to try to control how much loss is happening. So I use the same idea I've been talking about the whole time. These buffering spaces that have less controlled temperature requirements. So I don't have to heat a corridor to 20 degrees. So if it's 15 degrees instead of 10, for example, I'm already losing less heat than I would to the outside. Kitchen, very important element of any house. So there's a lot of heat gains that come from a kitchen, but you want to make sure that you're using them to your advantage. So the potential for ventilation of a kitchen extremely important, because if it's already a bit hot in your home, open your window, out goes that heat that you don't want at that point in time, or even for smells. So the ability to ventilate is always important. So I put all of this together and I created the different layouts, taking advantage of all of these elements. Another aspect to be discussed is openings. So we talk about window to floor ratios or window to wall ratios. So the idea is that, so a window is one of the weak spots in a house, because as much as you can allow your solar gains in when you want, you also have, it doesn't perform as well as an insulated wall, for example. So you do have losses through the windows, but we want that daylighting and we want those views. So not having a window is not an option. So what I do is this analysis for all the different units is try to understand where is the heat balance, where am I, what I'm getting from the outside, what I'm getting from my heat from the sun, when does it sort of equate to the losses? So that's what these numbers are actually saying. So up until, say, from 10 to 15, I'm decreasing the heat. So my solar gains are contributing. Once I start increasing the size of my window too much, I start losing more heat than I'm getting. So this is what I'm having to top up with. So I identify the sort of the area where that heat balance is. And then I know roughly the size, the amount of window I have to have for that unit. And then obviously, because in the south, I have the potential for getting that heat gain, I will have larger openings. And when it comes to the north, that I don't have any gains, the window is just losses, I will have smaller openings. So I apply that. And this was the final layout that came out. So again, those areas that I knew were going to be a bit troublesome to get solar gain benefits, I use for different functions. So I can store my bikes. There are ventilated bin stores. On top, there's like a small little laundrette. And all the units, see the red line? It's actually, so all of the blocks finish with the 2-story unit, and the stair access to the unit on top is actually my buffer space. So none of my buildings are technically exposed to the outdoors for that third complete elevation. And because obviously now I do have the potential for wind picking up speed through the development, I introduce then some devices to try to control that. This is sort of the device that I use. And I actually got 65% of replacement, and the original schemes were getting around 45%. So I do, again, the same exercise of trying to understand the daylighting, which I have 2% in the middle of the plan for all my units. And here I saw, this is where I could actually physically see that there was an issue with the wind. So I introduced those devices I mentioned earlier. So a day in the life of someone in that house. So I have those 3 periods of the years, which I need to sort of carefully analyze. So I get typical weeks and I look at that to see how my building is actually performing now. So summer period, I am pretty much in comfort. It obviously depends on how much direct solar radiation I have or haven't, because that was sort of the intent of the design. And I start realizing there are some points that potentially I would have to address if I was going any further. So let's look at this day in the mid period. So here is one of the buffer spaces. Here's the entrance buffer space to the north and the buffer space to the south. So my temperature gradient from someone coming in, it starts at 8 degrees from the outdoors. And as soon as I come into this unheated space, I'm at 19 degrees. So that's the first temperature step. Then you come into the house, you're almost at 21 degrees. So you might be happy with that. But if you want it to be a little bit warmer, you can come in to that buffer space and take advantage of that heat that's there. Or you can maybe open the door and let that heat come out. Simple control measures again, because this is what we thought, what I realized from the little research I did with the families. So passive strategies for the windows. So I have like a net curtain so that you can have your privacy and still allow daylighting in. I have blackout curtains, like in Belfast at times it's like 11 o'clock at night and it's still bright outside. So having the blackouts would be quite important. And in addition to that, I also have a insulated shutter, because as I was saying, the windows are one of the weak points where we lose a lot of heat. So if we have these insulated shutters, we can close them in the winter and keep that heat inside of the house. So how does this new proposal perform in relation to what we had before? So we were at 40 degrees, and as expected, all 4 orientations it's very continuous because of that insulation. And we are now down to 10 kilowatt hours per square meter per year. So just to be clear, the insulation values, the fabric performance, air tightness, all of those figures were exactly the same. The only difference is using the design strategies. So bringing back the idea of being a mid-terrace and including all these buffer spaces that aren't heated, they just sort of separate, create this temperature gradient. So let's see how our proposal is actually performing. So this was, the orange was the 2012, and now we are talking about the green, which is the proposal using environmental design and passive design strategies. And yes, there is a little bit of issue with overheating, easily controlled through openings, but it does indicate, and again, if I was taking this further, I would start considering whether I wanted to have some sort of solar shading or not. But anyway, I actually now am heat-free for 9 months of the year, essentially, or maybe 8 months of the year. So further improvement, and this is just architectural work, it's design work. So how can we quantify this now? So what's the impact of the environmental design in carbon terms? So let's look at some numbers now for the fun bit. So remember way at the start, I mentioned embodied carbon. So the embodied carbon is for the manufacturing of the materials used. And so I did like a quick analysis on that. So I'm just going to highlight this, which are the areas of the 2012 and the proposal. So my proposal is slightly bigger, so I will be using more materials. Window to floor ratio is roughly the same, slight difference, but it is a bigger unit. And once I look at the embodied carbon of the materials used, again, just for the substructure and superstructure, I don't have any mechanical equipment in this quantified. There would obviously have to be something, but it's not quantified here. So the embodied carbon, it's roughly from 25 tons to 25.5 tons. And what about the carbon of that space heating that we need to keep the house, that additional space heating we're going to need to keep the house warm in those 4 months of the year or the 6 months of the year? So for the 2012, we're talking, so I use the kilowatt hours, the total for the year, and I multiply. This is a slightly old figure, but it's from December, and it's from it's an actual value. And it's 0.25 kilograms of carbon per kilowatt hour. So I have 760 kilograms of carbon per year. Whilst with my proposal, I'm talking 175 kilograms of carbon per year. So this is the last number, I promise. So I put that together, and in principle, we're building dwellings to last for 60 years. So embodied carbon, remember, it was slightly less for mine 2012, slightly more for my proposal. But once we look now at the energy being consumed, we are 70 tons for the life of this building for space heating. Well, it's the 25 plus the additional, and it's coming up to 70 tons of carbon, whilst for the new proposal, 40 tons of carbon. So what is a ton of carbon? Because these are like these magical numbers that we keep talking about, but how do you make these actually mean something? So again, I'm going to apologize because I didn't have time to do like an example for India, which I wanted to do, but I'll mention the one for the UK anyway. So it would be, so the 70 tons would be the equivalent of a lap around around Great Britain 24 times, doing a lap around Great Britain, or 24 return flights from London to Tokyo. Whilst for the proposal, it's 13 of both of them, either. So architects have a role to play in a net zero carbon future, and I think it is quite a significant role to play. Thank you.
All right, thank you for such an informative session. I think we really enjoyed how you've broken down every parameter and then checked the boxes of everything that we should consider as architects, starting from the city level and moving down to the block dwelling and meeting even the occupants and how they interact with the spaces and how that later on has an impact on the energy analysis. I think your informed design, the way you've taken an example and then broken it down to very tiny bits and pieces on where you made the design intervention, I think that was quite brilliant. And what I think students would really appreciate is how you brought down how the simulations helped you to see the impact of your design intervention. I think that is basically what we're trying to achieve when we're going for energy efficient and sustainable buildings. Thank you so much for that. We have received a lot of questions from our students, and I just hope that you will be able to address some of them. Some of them might be a little blunt. Sure, thank you so much. Some of them might be a little blunt, but I think it's just as important to ask them anyway. I think there was one interesting question that we had, that there seems to be a reciprocal benefit that comes from balancing heat loss or gain with the lighting environment that we want to achieve indoors. I think somewhere down the line, you've also mentioned that in your presentation. But is there a quantifiable measure that you can say that this is the cutoff I would like to achieve before I can go down or bring up and down the other parameters? Like, do you have a lux level that you wanted to achieve first and then go ahead with the heat gain, heat loss?
So you do have different spaces will have these lux levels that you want to have inside, and you're going to have to get them. So say like a school, for example, they're going to be quite specific for you to be able to read things, for example, or a hospital, like this minute work. But so all of the stuff, it's a bit awkward because you end up putting numbers to all of these things, and there actually is no recipe for it. It's just optimizing different things. So this site, for example, is so easy. It's not dense. I don't have particular challenges, like say if you have, depending of the site location or other criteria that you would have had to make. So this is quite easy. And the whole idea is that you make informed decisions. So you understand the consequence of what the decision is making. So say, yes, there might be a lux level that I need to achieve inside, but I also I may want the sun or I may not want the sun. I know where I want to position that light inside to those levels. So I control my openings, I control the position of my windows so that I achieve that. So it's knowing what you want and what you have at your disposal. And depending, you might have to do it artificially, but you try to maximize or to potentialize on the free energy that we have. So there is no actual sort of recipe. It's understanding what you have, what your parameters are, and how best you can control it. And it will vary from site to site.
All right, brilliant then, thank you. We have another question here, and I think this question was triggered by the fact that you've moved down the levels from city to block to a dwelling. So the question is, does architecture and urban design are two sides of the same coin, where the output of one affects the other? I think urban heat island is one of the parameters we can talk about. How important do you think is for architects and urban designers to work together? And how must the government policies encourage that kind of engagement?
So I did my degree in Brazil, and we are very much the same professional in Brazil. We start out, the degree is exactly the same. And then because you like one or the other, you move on. You specialize in that. So they are definitely related subjects. Definitely, you can't sort of isolate one from the other. And I think it depends very much on the size of the scheme you're going to be doing to know the level of engagement you're going to need. If you're doing one house, you're not going to be using an urban planner. Now, if you're going to be doing like a larger scale site or something, then that information starts being required to make sure that you have enough access and circulations and things like that. And obviously with your surroundings, you have to have that understanding. And sometimes the effect won't be for the adjacent building. It will be further down the line. And again, that larger scale becomes relevant then. And as to government helping out with that, I don't think the government has, over here, I don't think they do much as to make the two teams work together. What you kind of have to have a client that's willing to pay for the both professionals, and you just have to try to make it work. But everybody kind of is always going to try to do their bit. Look, my bit's more important than your bit. You will always have those sorts of problems. I think it's just the nature of the project. People have different opinions. But you do have to have someone that's going to pay for both fees, unfortunately.
Right, so we have an economic standpoint over there. I think keeping that in mind, how feasible is it to provide housing for citizens or with lower income and at the same time meet the principles of sustainability in a pro-ecological economic development point of view?
So over here, the analysis I did and the development I'm proposing is for it's social housing. The example of the 2012 is a social housing scheme. So in Belfast, it's a small, the north of Ireland is a small place. So it's easier to control it. And the government, you have these housing associations and they are very keen that people have the opportunity to live in a half decent place. So, and obviously when the premise of the thesis actually was looking at fuel poverty. And that's what triggered me into it. It's just because there is this other carbon side to it as well, but the reduction came from trying to have people not paying that much because at times you just really don't have the money. So in a place like Ireland, yes. As you could see at the end, it's slightly bigger, the house, but the bills will be so much smaller. So there is a direct correlation there. And I don't think that those additional, what was it, like 10 square meters will really, I don't think that that's what's going to break the bank. And the scheme, like there's a quality attached to it. You have all the spaces that we had in the 2012, which is what they're already doing. So I don't see a direct negative in doing the environmental design. And that's kind of like the point why I wanted to talk about environmental design. It doesn't have to be this thing that's going to cost an arm and a leg. You just have to carefully think about the spaces you have. What do you need in that space? And the occupant is important because of that, because he controls that. It's his comfort that's determining all of this. And again, you have it saying slightly higher cost, yes, but the benefits I think are significantly larger for the sake of 10 square meters, which you could maybe even make a little bit smaller if I tried a bit harder, maybe.
Yep.
So over here, yes, it is achievable.
All right, thank you for that. You went through a lot of simulations in your presentation. Now, what were the softwares that you used to create those models?
So wind and daylighting would have been Ecotect with radiance attached and WinAir. And for the thermal simulations, it was TAS.
I'm sorry, can you repeat that?
TAS,
Okay.
TAS CDSL, TAS.
Okay.
And for the shadowing bit, I just used SketchUp.
Mm-hmm. Okay. Okay, thank you. The last question I have is going to be very blunt, but I think this is something that everybody has a doubt over, especially in India and many of the other places that we spoke about. Are LEED and BREEAM certified buildings truly sustainable?
Can I not answer that? No, there is definitely an added value to it. There's definitely an added value. There's a lot of work that goes into it. But it's a way of forcing people to get certain results. Whether you really want to do the entire process of BREEAM, maybe you don't. But at the end of the day, so we struggle with this in the office a bit because some of the schemes, they don't want to go down that route. So they want us to develop our own sort of matrix for them specific to their site. But then at the end of the day, If they don't want to do it, they don't do it. Or even if they've done it, how do they show the world that they have gone through this effort? And when you have the certification schemes, you have, here's my piece of paper, here's my certificate, I have done all of this. So I think there is no correct answer. I wish that everybody always wanted to do the environmental side of things and look at the performance and look at biodiversity and looking at the quality of the scheme. But unfortunately, we're not there yet.
All right. Thank you so much for your direct and honest answers. And I think our students have really greatly benefited from this question and answer session. I would just like to hand this over to Shiva Shankari ma'am to provide the vote of thanks.
Distinguished guest speaker of the day, Kimmy Eldash, our beloved chairman, Professor V.R. Rajendran, respected director, Professor Vinod Vijay Kumar, honorable professor, and my dear students. It's a great honor to propose a vote of thanks to all of us helped in making this webinar a success. On behalf of CAAD management, faculty and the students, I'd like to thank Kimmy for immediately agreeing for this webinar when I approached you. I really thank you for being here today. And I also like to express our profound gratitude to our chairman, sir, for his presence in this seminar. I also like to extend my thanks to our director, sir, for his constant support. And last but not least, I also thank our technical team, Professor Dushyant and Elil ma'am, for making this webinar possible. Finally, I'd like to thank the entire CAD team and wonderful students who turned up in great numbers. Yeah, thank you, everybody. Have a great day.